Hello, in this video we will review your high school math about conversion of Cartesian representation of a point to polar representation. Consider that you have a point here on a 2D plane. Where we can so let's this point to be C. This C could be represented by X coordinate and Y coordinate, so we could say this is X and Y, or it could be represented by this distance and this angle, which could be represented by R and theta. So the relationship between xy and r theta is that in this triangle, this height is y and this is x. So obviously we see that x is equal to r cosine of theta and y is r sine of theta. Obviously r is the distance, so it's always positive, and theta is between minus pi and pi in order to cover the whole 2D plane. Now if you consider, so this is the first set of relationship. If I calculate x to the power of 2 and then plus y to the power of 2, I will get r2 cosine of theta to the power of 2 plus r2 sine of theta to the power of 2, and then this gives you r2. Now if you calculate x square root, so r will become a square root of x2 plus y2, and from here you see that this shall be non-negative. Now if r is non-negative, theta should be between minus pi and pi. So theta is this angle, which is a kind of arctangent. But the problem with the arctangent, if we divide y divided by x and then apply arctan, what happens is that if your point, instead of being here, is in a symmetrical point here, so which is at minus y and minus x, in that case you'll get minus y divided by minus x, and arctan of this point will be equal to that. So in other words, when you do the division, the sign bit, which represent if your point is in the right side of this y-axis, or if it is the left side, if it is in the fourth quarter, or if it is in first quarter, will be lost. So this is why in MATLAB we use another function which is in MATLAB is written arctan2 is another letter, and then you put x comma y. You don't divide y by x. So in that case there is going to be a one-to-one relationship between these two. In other words, if you have x and y, if you have r and theta, you give it to this box, and then here you get r cosine of theta is your x coordinate, and then you get r sine of theta, it gives you y coordinate. Or you could do the other way around. So if you have r as input, theta as output, you can if you have x as input and y, so you calculate a square root plus y2, this gives you r, and then you calculate arctan 2 of x and y. Okay, so in MATLAB you put an extra 2 here, and this gives you theta. So what you see is that there is a one-to-one relationship between this pair and this pair. So it's a 1-to-1, 1-to-1 relationship. So r is the distance and theta is the angle. So if you look at your sample space, C is a point in 2D, which could be either represented by XY coordinate, or it could be represented by angle and distance. And you see that Cartesian to polar conversion is very easy.